Okay, last two problems. You can look at these on your graphing calculator, but you can also do them without your calculator very, very easily. Um, so what I'm going to do is I will do them without my calculator. Maybe pull up the picture to double check. I think that's a good way to tackle this. I'm going to start by just identifying my key points here, or my transformations. Here my amplitude is 3. The period, there's no number in front of x, so the period is 2 pi over 1, which is just 2 pi. I have a phase shift. My phase shift is going to be pi divided by 1. And it's plus, so it's pi to the left. So I'm going to start, if I'm 8 spaces out is 2 pi, so that means 4 is going to be pi. Negative pi, negative 2 pi. So my starting point, where I'm going to start, is going to be here. I'm going to start my cosine graph. And remember, cosine looks like this. The cosine parent function looks like that. It's the u instead of a. So I'm going to start with an amplitude of 3. Here at negative pi 3. My period is 2 pi, so I'm going to get the next point done at positive pi. Halfway in between, I have that minimum point. Halfway in between, I cross the x-axis. So cosine, just in 3 cosine of x plus pi will look like this. And if you're feeling like you want to check that at this point, then go ahead and double check that. So just a quick double check of my shape there, and that looks pretty good. Okay. Now we need to do the absolute value, and that's why I just dotted this in. So what the absolute value does is it takes any points that drop below the x-axis and basically flips them up. So this point down here at 0, negative 3 is going to come up to 0, 3. So this one period of this function is going to look like this. It's more like bounce it up. There we go. And then you can just continue that pattern in both directions. And that's 3 cosine of x plus pi, the absolute value of the whole function. For tangent, remember tangent is our graph that's a little bit different. Tangent has a period of pi. So here we have a vertical stretch of 2. Remember, tangent doesn't have an amplitude since it is infinite. And then here, our usual period is pi, so we're going to do the period is pi divided by the number in front of x. So that's going to be pi times 2 over 1. So the period of tangent is 2 pi. Now, remember, tangent is centered on the y-axis. So usually we have asymptotes at negative pi over 2 and pi over 2. And our guy looks like that. So if we're doing a horizontal stretch of 2, we're going to move those asymptotes out from pi over 2 to pi. And from negative pi over 2 to negative pi. We don't have any movements up or down. We're still centered here at 0. And instead of going halfway in between our 0 and our asymptote and going up 1, we have a vertical stretch by 2, so we're going to go over 1, up 2. Usually our function kind of looks like x cubed and then it's increasing like this. But since absolute value, what happens is that little branch there to the left is going to flip up. So it's going to look like this. Now, if you have room on your graph, you need to keep graphing. So we're not just doing one period of the function. You need to come over here and finish that guy out as well. So it kind of looks like pointy parabolas, just flipping those kind of bottom branches up. You can absolutely check that on your graphing calculator. Make sure you feel confident about where to get that absolute value function. And the TI-84 is under the math menu. It's ABS, so it looks like this.